Hello and welcome again to Astrobits, and I'm Dr. Priya Hassan. And I'll be continuing with the topic that we were talking about in AstroCon today, which is about how dark is the sky and how dark is space. So this is what we actually call the cosmic optical background. Now, so the question is space dark? Is there something like a background radiation? We know that in the microwave, we have a 3 degree Kelvin microwave background radiation. This is an indicator, it's all over the universe, and it's basically an indicator of the universe cooling down after 13 billion years after the Big Bang. And what about optical wavelengths? Is there something similar? So we have some new results which have come from the New Horizons spacecraft, which you can see over here in the image. This is the New Horizons spacecraft, and this was the first spacecraft to actually reach Pluto very close and took very good images of Pluto. This was in July 2015. And at present, it's at a distance of about 60 AU, which is about, an AU is the distance between the Earth and the Sun, which is approximately 150 million kilometers. And light would take approximately 8 hours, 14 minutes to actually travel from New Horizons to ours. It's that far. Okay. So what was there is New Horizons could be very well used to actually study this cosmic optical background, to actually see is there a background glow in empty space which you're getting from the light of galaxies and optical objects. Now, this is obviously different from the microwave background radiation, which is actually radiation from the Big Bang. This one is basically radiation which is from all the sources which we have. And that is why it can be very well used to compare with what is our estimate of the number of stars and galaxies in the universe. We just spoke about that in AstroCon, the number of stars and galaxies in the universe. And we want to use this to actually compare with the numbers and see whether the amount we are getting from radiation from these objects, as it compared to the background. Now, one of the most important nuisances in actually measuring this is zodiacal light. And zodiacal light is nothing but the diffuse glow of sunlight scattered off interplanetary dust. It's barely visible from dark skies on Earth, but when it comes to knowing the blackness of the sky, the zodiacal light is very, very bright. And therefore, there were earlier measurements made by the Cosmic Infrared Background Experiment, CIBER, which actually flew aboard a whole bunch of sounding rockets, but it's still not very sure about the results we got from there. Now, New Horizons is well far away from the Earth and far away from the zodiacal light, and therefore it was considered a good instrument to actually use to measure this. So the astronomers used the long-range reconnaissance imager, which is called LORRI, which is the instrument aboard New Horizons, to actually estimate the intensity of the COB. This was done in 2021 as well as in 2022, but they found double the amount of radiation thought to be emitted by all the galaxies. Now, this is obviously a confusing result because this basically means that we have not correctly estimated the amount of stars and galaxies in the universe, and maybe there was a consensus that maybe there's a distant population of faint galaxies which we have not estimated, and something even more exotic, which was axions, which is a hypothetical particle candidate for dark matter, and whether these are the particles which are actually emitting invisible photons. So therefore, people were very interested in actually measuring this because it could actually have some very important implications in cosmology and our understanding of the universe. And now finally, through LORRI, we actually have an estimate, and here you can actually see is that it has 16 images. It took 16 images basically at different wavelengths, etc. And what you see is that for the values it got, it actually we actually have estimates of the contribution. For example, the dark blue is the faint galaxies. There's H alpha emission. There's scattered galaxy emission. There is faint stars in green. There's diffuse galaxy light, which you see over here in beige, and then in yellow, the scattered starlight. So therefore, there were various sources which could be possible emitters, and therefore, using these 16 instruments, what we found was something really very satisfying, is that basically what we get is that most of the radiation which we can is what we actually already account for. This was actually published in a paper in Astrophysical Journal this year by Postman et al. You can have a look at the paper, and you can actually see that this, so what's nice is sometimes in science it's good to have non-exotic results, where actually we see that the amount of light we actually observe has been well accounted for, and therefore it basically gives us that there's no evidence of significant levels of light produced by sources which were not known to astronomers, and therefore the new result is very heartening. It basically tells us that our present understanding of the COB is satisfactory, and we do not need to think of the earlier model which we had, where we had to think of potential dark matter candidates or a distant population of faint galaxies. We do not need to think of those objects. We probably have estimated the light well enough. So this is quite a good heartening result, and thank you.